Hey everyone, today we're joined by Ryan Carniato, the author of SolidJS. I'm excited to have him on the stream because I've looked a lot at SolidJS and it shows a ton of promise. Today we're going to be walking through how SolidJS works under the hood, as well as a little bit of how you can utilize it in your applications. I apologize in advance for my audio. There was some technical issues going on, but it's resolved about halfway through the video. Overall though, this is an awesome conversation you won't want to miss. Stay tuned. Welcome.
Hi, thanks for having me.
Yeah. So first, there's always a person behind the screen, right? That's like kind of my go-to motto. I would love to hear about you. You mentioned being in a band a little bit earlier when we were off camera. I would love to just hear about yourself. Who are you? Like, what's Ryan all about?
Yeah, sure. I've been programming and playing music since about the same time. When I was like 10 years old. Those are like my two things. I wanted to play in a rock band, or I wanted to be a developer. Those are the things. And I actually started down that path at that time. I started my band when I was 12, and I learned Quick Basic when I was about 11. So I was doing those both all through high school and even into university. And at the time, believe it or not, when I went to university, I actually chose the band over school, and I left university and I did the band for several years. We toured. I played over 500 gigs across Canada, the US. It was a pop punk band. We were called. This will be relevant. We were called Mr. Solid, and it was named after a chocolate Easter bunny that we get. I'm Canadian. Grew up in Vancouver, British Columbia, and I don't know if those are available everywhere. There probably are, but essentially we were playing that, name the band kind of game, and you're looking around the room, and so it was like shortly after Easter. And there was a box sitting on the table, and for some reason it stuck. Maybe the double entendre or whatever. Being a pop punk band and being kind of cheeky. But yeah, I played music for a long time and developed for a long time, and then at a certain point, the music stuff kind of went to the wayside. And I got a real development job, and so on. And this continued on with my stuff. But I mean, I'm kind of giving away a little bit on my age there. But I kind of went back into development during like the heavy .NET time period, and essentially I cut my teeth on the web when it was just like basic HTML and JavaScript, and this was like a very different sort of paradigm. I was familiar with it because I dabbled in game programming and I'd done DirectX and stuff like that. So I was like, it wasn't too bad, but that's how I came back to the web. So, a couple of years later, 4 years later or so, when the front end framework started emerging in JavaScript, I hit my stride. I came across Knockout.js, thankfully, because this was a Microsoft shop I was working at. They were like one of those third party, like sponsored by Microsoft kind of, places where everything was Microsoft. And Knockout came out through that. Steve Sanderson worked for Microsoft, so it's kind of common as a way of adding extra JavaScript interactivity to your .NET pages. And I just went all in at that point. I stopped like doing back-end code or that, and I was just like the specialized JavaScript widget plugin person. And that's like, as I said, where I found my love for reactivity and a lot of the stuff that I love today. But it was a long time ago. That was like 12 years ago. So I've been just doing reactive programming and JavaScript pretty solid in the last decade or so. So that's kind of been my story.
See, here's my thing. I can't tell whether you said pretty solid as a joke or like whatever, but it works perfect. Like it flows very well perfectly, right? See, I love that, right? Like you have that experience from like the .NET ages, right? And back when I heard the word widgets and like just this rush of nostalgia about like, building old web pages back in like, MySpace and like before then was like all the rage, so that's awesome. So for those that may not be aware, what is Mako?
So what is what?
You said that you had worked on Mako, I believe.
No, Knockout. Sorry.
Knockout.
If the audio, I hopefully you heard that. Yeah, Knockout.js. It was a JavaScript framework that came out of Microsoft like 2009, 2010. It was at the same time as Angular 1, and like it was a little bit after Backbone, and it was basically a library for making declarative UIs. And the whole premise behind it was, instead of having a bunch of like heavy life cycles and like all these like MVC things, it's very common back in the day to have like MVC was the thing, like it's like model view controller. Knockout was kind of interesting. They called themselves MVVM, but the library itself was just basically the VM part of it, and the view, I guess. It was essentially, you only worried about the state and the view code. You didn't really worry about the backend data model. So you kind of plug in your own data model, and then you'd have this view model, which is a little bit different than a controller in MVC. A controller is a single instance that directs traffic. A view model is instance-based. So you'd basically make these functions that you would create some kind of state with, and then have those bind to the view. And what I love about Knockout is, in hindsight, it was very, very modern for its time. Like 2010, if I pull out some Knockout code for you, you probably go, oh, that looks a lot like Solid or React hooks. It was basically this method based on these composable reactive primitives. And I loved it so much that when it kind of fell out of favor, I never left. I just wanted to keep on building Knockout, and that's really where like SolidJS came from.
That's super cool. So I actually just wrote an article recently about like history of like web development, like going back to 2010. I don't know how I didn't run into that, because I like specifically was asking people like, oh man, like what do you remember for 2010? So we had like Knockout.js, and there was another one that started with a K. It was like, I don't remember. It doesn't matter. Yeah, that's super interesting. I think that history of like 2010 web development is where JavaScript frameworks really started to like launch off. So there's a lot of really interesting concepts that were developed at that time that I think was really interesting to hear you kind of directly reference that as an inspiration for Solid.
Yeah, I mean, the truth of the matter is, JavaScript was not amazing to use before 2007-ish time period. Like I recently did the State of JavaScript survey, which people should do if they get a chance. It's a little buggy, but if you make it through it, it's worth it for supporting things for people, projects, whatnot. But I got to a question, and they were like, how did you learn JavaScript? And my answer wasn't on the list. I learned it by going to other websites and viewing the source code. And this kind of simplicity for JavaScript was great, but it's also because you couldn't really do anything with it, like not actually that much stuff. And it wasn't until Ajax, or the ability to do these like asynchronous requests in the browser, became possible around 2005, that people were like, oh, this could be an app in the browser. And more so, all the browsers started investing around 2007, 2008 time period. You saw V8, Chrome, SpiderMonkey, WebKit, like all the modern engines were developed primarily during that time period, and they took what was JavaScript previously and like 10x the performance over the course of like a year or so. Like it was an incredible jump, which suddenly made this whole zone viable. It's why Node.js was viable, right? V8 was so much more performant. Like essentially, this was so revolutionary. There's so many ideas and so many things floating around. It was inevitable that we'd have to kind of settle on best practices and kind of follow those goals and kind of cut through the huge amount of innovation going at the time. But what it meant is there's a lot of really cool ideas that were left on the table, like things that got kind of developed out and then kind of just like dropped off because that wasn't where things headed or consolidated. But it was kind of wide open then. And I think we're seeing a lot of those ideas become relevant again right now.
Yeah. And I think that's super interesting as an idea of like looking back to the past to go towards the future, because I remember when I first learned about Node, I was like, oh, you're telling me that like there's like the concept of asynchronicity really threw me for a loop, because that, you know, like I was learning JavaScript around the time, and people were like, oh, and look, the browser can live update. And, you know, I was like, what do you mean it can live update? Like, what do you mean I don't have to write jQuery all the time to be able to update the DOM manually? So I definitely think that there's a lot of interesting concepts that were developed at that time. And to see us going back and relearning some of the lessons that were kind of, as you had mentioned, left on the table is super cool. Do you want to like showcase some of like what those ideas were, like what the reactivity system in Solid might look like?
Yeah. I think that's a good segue. If we want, we can kind of go over there, because I mean, that was sort of the starting point. I can actually, if you want, we can share my screen and we can do that, because I want to step back a moment, because I feel like for me, people see Solid and they see React, and they kind of do that. I don't know. Is my screen being shared now?
Yeah.
Okay. So I'm going to do something even more simple. I'm in Solid's playground. Hopefully the size is big enough for people can see it. But the idea that Knockout had, and by the way, we'll talk about being ahead of its time. Everyone, you know, gave big praises to Svelte's interactive tutorials, and since then, it's been like literally copied by every JavaScript framework. Knockout had really, really good tutorials, like even back in 2010 and 11. It had the interactive, like, here's the lesson, here you type the thing, press the solve button. Like that formula was they had back then. I mean, it's so funny when I go there, because the site, actually, I'm going to pull it up right now just so you can see what I'm talking about. The site hasn't actually changed that much. Maybe like probably hasn't been updated since 2012 or something. But like it has like here we are, tutorials. Like it's a little bit different. Start over. But like, you know, you have your HTML view, you have your JavaScript code, and then you have an output, and you go, oh, I'm getting stuck. Help, it's not working. And, you know, this pattern I find very great for learning. But yeah, sorry, that was a tangent. I just wanted to show people this very awesome framework from back in the day. But going back to where I'm getting at is, with Solid, we have slightly different primitives than React hooks, but when I show people React, that's essentially what they see, right? But for me, the starting point for this is Solid's kind of a state library, is almost the best way I can put it. So you might declare that you have maybe, let's just do the classic, you know, you have a count. I spelled it wrong, but
always with live coding, right?
Yeah. You gotta love the TypeScript autocomplete though. This makes my life a lot easier here. Yes. So you might like, if you just started from the beginning and you go, I have some state account. And then like, honestly, you could start like, I'm just gonna, let's go even further back, right? You write your first thing, and you might go like this. And then you might go, let double count equal count times 2. And then you might console log double count. Now, as we all know, this is going to be pretty uninteresting. Maybe I should make it 1 so we can at least see something here. But you know, we console log 2, right? But what I'm getting at is, then later you're like, count now equals 2, and you console log double count, and unsurprisingly, it's still 2. Like, so you're like, okay, I need to write the code again. So now double count equals count times 2 again. And I mean, that's not a big deal, but that's kind of a pain. So you might go, okay, let's abstract that. And just bear with me.
No, you're good.
Yeah, double.
I think stuff like this really helps like sell a framework, you know, like being able to understand the core concepts at play. And this is really helpful. So.
Or let's go double a number. It doesn't have to be count. It just has to be double a number. And then you might be like, okay, well, let's return num times 2. And now you're like, I've abstracted this away. So now I'm not repeating my code. And sorry, it's count. But what was really magical about reactivity was changing this model to be declarative, almost like how should I put it? Almost like an HTML is declarative or SQL or something. Essentially, make this relationship into a rule that was true. So, essentially, back to our create signal example here. Signals are a variable, except you access them by calling a function. So we could essentially, if I got rid of this count here, essentially we could do something similar if we called this count as a function, and then we go set count to 2 now, and then call this count as a function. And I initialized it. We have our same example, and I mean, this is not anything fancy, but where the interesting part came in is, what if we could essentially, what should I do here? Yeah. Let's start with this. What if we could make that relationship hold through time? And this is not a new concept to a lot of people. They've probably seen this before. But I'm just going to skip double count for a second, but I'm going to go console.log count our function times 2. Now, I'm going to comment all this away for a second and make sure that I am on the latest solid. Second, let me refresh. Yeah. Okay. Yeah. Okay. So this is just, so far we set a value and we ran this effect. We ran the statement that does 2. But where the magic comes in is when you set this to 2. Batching. Ooh, okay, sorry.
That's actually really cool that you already have batching enabled.
Yeah, it's only because of top level create effects. I should have tested this example before. You get the rough version. You get the rough version of it. There's another primitive in Solid that does almost the same thing, and it's okay. This is what I was actually going for, which was. Once you create that signal, and then once you set this rule about count, we can set this count as many times as we want to different values, and that rule holds. That's like the magic of reactivity. And once you do that, you realize, like, this original code, you could picture what you had to do to, like, keep on, every time something updates, you have to update everything related to it. Even if you abstract it into a function, you still have to do that. Whereas, like, with this kind of model, you could just kind of set it once and forget it, right?
Right.
And what really attracted me to this was just how composable that was, because if I wanted to, I could be like, oh, let's make a double count. And that double count is also a function like our thing. And it's just count times 2. In fact, this is not that different from this double num that we wrote earlier, except now it's just a function that does this. And what's cool about that is with reactivity, essentially, we've now abstracted out this thing that we can use the same as that original signal. Everything is just this function, and you can pull it out and transform it however you want, and it's still going to do the same thing. Now, I don't know if that's clear to people how that works, because it seems like magic a little bit.
It's really, really cool and really, really magic.
Yeah. And I've gone into the past a bit on how that works, but the essence is the secret's all in the functions. Yeah. What we're doing is we're pushing some kind of global state behind the scenes. So whenever we run one of these wrapped things like a create computed or hook, it pushes itself onto this imaginary stack. And I could probably pull up something where I show a quick example of that, if that helps visualize it a bit. because I'm trying to think of where the best version of that is. Probably, give me 2 seconds. I should have probably
you're good.
preface
hide your screen while you're looking.
It doesn't matter. I've written so many articles here. What I wanted to do, this I guess this gets a little bit more complicated than the most basic version of this idea. So I mean, I don't want to get too crazy on here, but essentially, this is create signal for anyone who's interested in its guts. Let's run through this code snippet. This is as technical as I probably want to get on the internals of Solid here. But essentially, when you create a signal, you create a set of subscriptions. And this set of subscriptions is basically all the things that could possibly listen to that signal changing. We've kind of just inversed that model. Like if you use promises before, you've used subscriptions. Like every time you put a dot then on the end of it, you're basically subscribing to that promise. The promise only runs once, but if you had an event, the same idea. If you have an event, you can add as many event handlers as you want. When it updates or new event fires, it tells people. Signal is a very similar idea, except the little piece of magic is we have a function to read it and a function to write it. And the write is really simple. We just set the new value and go through our list of subscriptions. Don't worry too much about like the spread thing I'm doing, but essentially just run all the subscriptions. This is just like run this subscription. So, like whatever handlers you add to that signal, it's just going to run them. So new value, tell them about the new value. But the read is this kind of little magic that kind of gets people. And the idea is we have this sort of global context. And whenever a new context is entered, like a create computed or create effect, it pushes itself into the stack. So when you read, the signal can go, what's the top of my stack? What is this computation that's listening to me? And if there is one, have it subscribe to me. That's the gist of the mechanism. So it just creates the subscription. If we go back to our playground here, when this runs, it pushes itself on. And then whenever you read this, it goes, oh, you read double count. Well, double count is just a function. There's nothing special. So it just executes. But then when it gets to count and the count is read, like I showed, it goes, oh, what was the thing on the stack? Well, it's this computed. So when you update this value of count, call this event handler again, essentially. So every time we update count, we just call this and it console logs it. That's essentially the gist of reactivity. It's an event system. Right. Does that make sense?
Yeah. I think that makes a lot of sense. It's using like functions and like getters to be able to access the values properly. The part that I thought was funny is seeing the spread. You said don't worry about it, but I know exactly. Like I've ran into the set spread issue like multiple times because it's technically not an array because
yeah.
But really, really cool stuff. I think the part that really impresses me the most is that you're able to just do this without creating a component instance, right? Like, there's not that many component frameworks that can do that.
Right. And this is why I started here, because this mechanism of updating it's just a pattern. It can be built into the JavaScript standard or whatever. There are, in my opinion, defined primitives that you'll see in every single framework. Like maybe it's a language level consideration, maybe it's a mechanical thing, but there's always this concept of the signal, or the atom or whatever, like this data that's mutable.
Right.
The concept of the side effect, like I'm doing here, and then this concept of deriving that value. Basically, with those three concepts, you can build lots of stuff. And if you've used other frameworks, you've seen them, right? In React, it's use state, use memo, and create and use effect. In Svelte, it's let variable, $, some expression, and then $, variable declaration, and then $, expression. Like Vue, like they all use this kind of same language. The interesting part for me was this Knockout had this. They had observable, computed, and pure computed and computed. They had these three things. And you could just do anything with this. Like when I first used Knockout, there wasn't like component frameworks or whatever. It was just like, use this to update your UI, because people do this example and you're like, okay, sweet, it updates stuff, but it doesn't take too far to kind of, actually, sorry, I deleted too far to kind of go, okay, well, wait a second. What if we change this a little bit? Why are we console logging? What if we were doing something else? What if we were like, okay, and this is some DOM API, but let's make an element. Let make a document.create element, an H1?
Okay. Yeah.
Yeah, like let's just people don't always use this, but like we're just doing vanilla JavaScript here, and we've got this element, and let's append it to our document. So we have this is our mount point that you've used in React. But let's just go append child our element. Now we're not seeing very much here because the element's empty. If I wanted to, I could go let make the element text content equal hello, right? This is vanilla JS, no framework kind of scenario, right? You can forget about this. We just create an element, we put some text in it, and we added it to our page. I mean, I was like, well, what if we could just take this and stick it inside our effect or computation, right? Like, why can't we just do this, right?
Right.
And let's watch. See, this is going to be so fast, you're not even going to see it. So,
timeout maybe?
Yeah, exactly. So and we can go back to create effect because now the batching won't matter. It was just weird top level, but let's there's slight benefits to create effect in terms of execution timing. But yeah, sorry. And I was showing double count, wasn't I? Double count. And why are you complaining? Oh, because of whatever TypeScript. So let's just add a couple timeouts. Let's go set timeout, and we'll make this one happen after 1 second, and let's make this one happen after another. Let's make it just 3 seconds, and then we do this. Okay. so like a little bit longer bang, right? Like this is vanilla JS rendering, right? Like once you have a mechanism to do state management, and it doesn't take very much. This article that I wrote that I was showing this is fully works, this example here, even though it's like very, very simplified. And the whole thing is about 50 lines of code. So 50 lines of code, and essentially you suddenly have this superpower where you can just model things declaratively, and just there you are, like you're updating the DOM. And honestly, I'm not going to recommend people do this, because this still gets a little bit, a little bit heavy to do yourself, right? Because let's say the set timeout isn't good enough for you, then you're going to be like, well, actually, I want a button, right? And you kind of sort of see like this just takes a lot of, it's not a lot, but it just takes like a bit of let's actually, I'm just gonna, can I just do this? Like I can never remember. Yeah, I can do that.
I don't think you can. Oh wow.
Yeah, and then let's give our button some text, which is what button. Or is it value? It's value equals no.
I always do our text.
Yeah. Okay. So click me. Yeah, I'm a text content person. They're similar. Text content is slightly more performant. This is one of those things that I find out by benchmarking. There's some different in the way how they parse. But my point is, you'd have to do this, and then you'd be like, okay, well, then what do we want to do? We're going to go button on click, I'm like add event listener click. I mean, I could do on click actually. No, let's screw this. Yeah, let's do on click. It's even simpler. The browser has this built in, so we can just go like this is going to not have our nice time thing, but we should be able to, yeah. So it's just 2, then we click on it, it changes to 4, right? I mean, this is not terribly surprising to be said, but this is just vanilla JS programming, and it's hard to I could do some stuff myself without the reactive system, but this effect removes a lot of my complexity. But in the end, I'm literally just changing the text on this one DOM element, and I'm not really I had to do a bunch of wiring to do that. This doesn't scale, but it's really, really quite nice.
Cool. This is one of the coolest demo, because I think the part that I really appreciate about this is that it really represents how powerful, but also how simplistic this reactivity system is, right? You don't have to have I think when I started programming, I felt I have to have this PhD in computer science to be able to understand how this reactivity system works, right? And in reality, it's you can build something with this system, right? This can be powerful and you can utilize it properly. And that is so cool to me that you're able to demonstrate using just vanilla JavaScript how this is working under the hood. And especially without a component instance, right? We mentioned React isn't able to do that state management without a component in place, because that's how React works, is that it's explicit calls to be able to manage the state. So this is really, really cool to see.
Well, and that's the thing. I don't like writing document.create elements. So why don't I just have something do that for me? So why don't I just make a JSX element here and do the same thing? And if you notice, me changing that to JSX didn't actually change our behavior, because if we go over to this compiler, it's doing a little bit different. It's doing a clone node, but it's just creating these elements essentially. So you can just pretend it's that document create element. Now we just have H1, and it's a little bit easier because I don't want to, for the text here, it doesn't really matter, but for the button, I don't want to right click me, right? I want it to, why don't I just go like this and just go click me, and then now I don't need this, and I don't really want to write on click, so why don't I just write on click, and then put this in here. And I haven't tried this demo exactly. This is my first attempt at doing it like this, but what I wanted to show is that this should still work, because essentially we're just using the JSX to create DOM elements. Now, it's just a convenience. It's a shortcut over it. What's actually happening, you already saw what the compiler did. It was what you hand wrote. Solid doesn't do much more than what you hand wrote in that scenario. Now you just use JSX to essentially do this. And for the final piece of magic here, what if we do set the text to the H1? I don't want to write the effect myself either. What if I just wanted to grab double count and put it here and get rid of this? If everything is going well, it still works. This just compiles to what we were doing before. Essentially, this is just as performant. It's just literally changing that little piece of text there, except instead of calling document create element yourself, you just did this. And so we haven't created a component yet, as you said. This that's so cool. So it's kind of, so on one end of the spectrum, Solid's kind of like maybe like jQuery. I hate to say it, you're it's a declarative version, but you're just doing this stuff. But we're there's just conveniences here, because you don't want to append element buttons. So maybe it's time that we want to make this reusable, or we want to kind of abstract it out a little bit. Just having the stuff spaghetti code at the bottom isn't the best. Let's just maybe put in some stuff like this into here, and then we don't need these variables or whatever. Let's just do this. Let's return maybe like a fragment or something, and then kind of take this and take I always love the playground.
It's trying to help. I swear.
It is trying to help. Yeah. And where was it? It was H1 and then the button, and then we'll just kind of remove that. And okay, so now let's just kind of lost my formatting a little bit, but I think usually like prettier does stuff like this. We had prettification here. I'm just not seeing it right now. Like literally there's a panel here or was whatever. Okay. So, and then let's instead of appending it manually, because there is some stuff that's a little bit, I mean, we could keep on appending it manually, I guess, but because there's some stuff that's a little bit tricky, where we have top level reactive values that change and stuff like in fragments and things like that, the DOM doesn't understand this fragment I'm returning. I'm going to, it is an array, honestly, but I'm going to import SolidJS web render, and then we will just render our app to this element. And we are basically looking at something that you probably go, oh, it's React. But it's also not React. This is actually the same as the code that we started with a few minutes ago. It's doing the exact same thing. We scale up from just being like a state library that you could literally use with React. There is actually React solid state. You can actually use it to drive React, you can make it drive vanilla, to basically an abstraction that works and scales with your apps. Like this abstraction is really powerful. And the thing is, this might look like a component, but I've already showed you, these are real DOM nodes, right? And when I console log here inside, this is only going to print once, and even when I click it, and why shouldn't it? Because as I just showed you, this is just a function. There's no component here. Even when it looks like a component, there is no actual component in Solid here. I just made it a function because it was convenient. Like I didn't feel like having this all top level, so to speak. But I mean, what's the difference if I have that here? Sorry. Have that here or put it here, we don't really care that much. There is a difference here. This came up recently on a stream, was that if this was say a counter here, and let's make this, I'm going to just make this render function, and let's just put, see, maybe more like this. If I was just to make this another fragment, and we were like, oh, we have one counter and we have two counters, there is a difference, because when I click this, they both update.
Right.
And if I put this inside, so to right here, now only the one that I click updates, because the state was created inside that function. So there's one per, otherwise it's shared across all. So basically the act of us moving the reactivity that signals out of our component, it's not really a component, is just how you do global state management. It's where we started. We started with global state management, but you can always just scope it by putting it in a specific function, because of this magical thing in JavaScript called closures. But in this instance, closures are working for us instead of against us, because we're not worried about some outer context rerunning and going, oh, what's the latest value as a scale? The thing is, this function runs once, because that's really what a function does. You call it and it runs, and then it's actually these closures, like around these expressions, that are storing the value. There's no component instance. It's just you made one of these, and now it's part of this.
This is so cool. So we've got a few comment quote. I love how he started with basic reactivity, showed it working with vanilla.js and layered JSX on top, so for logical progression. Simplicity is the best thing on Solid. Love the simplicity of this. React hooks for vanilla.js. Yeah, like this is so very cool to see in this progression. And I think it's important to highlight is that like this isn't just like some theoretical look at how cool this is, whatever, right? One of the things you highlighted on the website is web components, right? This seems like an amazing fit for like, let's say you need a component system that works in multiple different frameworks, which is super common in large enterprise, right? Being able to build something like that and have that shared state and be able to have stuff. I think there's something with the mic you're using. Here, let me switch over.
Sorry,
this is really awesome stuff.
Sorry, did something happen? Is it okay now? Can you hear me?
No. So someone is saying something wrong with my microphone. So
okay.
Switch over. I have two of them right now.
Okay. Yeah. To that point, which I agree with. Web components. I owe a lot to web components, which is kind of funny because I was a huge proponent of them, and less so now. I'm actually a little bit vocal about how less so I am now. But web components are the reason that Solid doesn't have a component system. Really, when I started Solid, I assumed that I would just use web components with it. Like I would just be like, oh, I don't need a component system. People use web components. So my first open source library was like a generic web component library, kind of like people seen stuff like Skate. My problem was most of the framework agnostic solutions didn't work with reactivity. They expected things to re-render all the time. Right. And I've hit this my whole career. That's why I've also kind of developed this thick skin against things that claim to be framework agnostics. Like 90% of the time, it's not true, but there are those 10% where they actually do, like Astro, like big props up to them. But like most of the time, that hasn't been my experience. And but on that end, I was all in on web components. My early stuff with Solid was based on web components. My first Hacker News example I built with web components. I'm hearing a bit of an echo.
Oh, is there? Okay. My bad. I changed the setting. Echo cancel. Okay. Let's try that again.
Yeah. So my first Hacker News demo was done with web components with Solid. And basically, as I mentioned, my first open source library, back in 2014, I authored my first router, which was like a nested router kind of approach. And it was all in web components. It used slots to do the different nested levels and stuff. I was all about web components, but at a certain point, I'm an avid benchmarker, and I realized I'm like, web components are part of the platform. That's great. You should use the platform. I'm using vanilla.js like as performantly a thing. The problem is web components were less performant than other parts of the platform. Like essentially, like they're good, but what you're doing the second you move to a web component, you're deciding that your component should be a DOM element, and there's trade-offs. Like that's essentially the thing there, right? What's the lightest possible abstraction we can have for a component? Well, my argument for that is the lightest possible abstraction that doesn't tie you into anything for a component is literally a function that runs once. Like so that's essentially why I've had an interesting journey with web components, because there's this very strong sentiment about use the platform. And trust me, you don't get to get the kind of performance benchmark scores that Solid gets if you don't use the platform. But it just, web components isn't really necessarily part of that equation. But web components have great uses. They're great for having a standard interface. If you want to put different frameworks and stuff together, you want to kind of have something work in isolation. For things that need strict boundaries, web components are unmatched. They're the only truly like standard interface for things to play nicely together. So they have lots of value in that sense. They're just not something I want to internalize. I don't want a framework of web components. I just want like a widget, the whole thing wrapped in a web component. So it's interesting because there's a lot of that kind of back and forth. And I as I said, if you keep the primitive simple and you keep the mechanism simple, you can do whatever you want. I made a Solid element so people can use web components with Solid, and it lets you just use components like this as the base of your web component. But like, it's really cool how, as I said, we started this whole example without the DOM. And that's the power of reactivity. It's completely portable and transportable, and the concepts stay the same no matter where you go.
Mm-hmm. And I think the really interesting thing that you're highlighting is that like there's theoretically is there anything that would even prevent you from using this as like a global store to Node outside of the fact that you want to usually have some persistence in Node or something like that? Like, would that theoretically work?
Yeah. I mean, sure. There's when people start coming to me about universal renderers and using stuff like it on native and whatnot, my first question to them was like, well, do I need to do anything? Like, because because we haven't looked at it too much, but if this wasn't H1 or button calls here, and we were just calling these components, like we don't actually import any DOM libraries. There's no actual there's no DOM here. This counter, like the capital C counter, solid, basically translates to counter. There's a little bit of a difference, which is in terms of how we kind of safeguard tracking and stuff. And the most important thing that our components do is they transform the props. So they make sure that when you write count, I'm just going to make something up, but count equals count, and you put something like this in here, they make sure that this just doesn't run right away like normal JSX. They make sure they wrap that in a getter. So the real magic of the JSX syntax is transforming the properties so that they're lazy here. I didn't really go into this. This doesn't use a standard JSX transform, mostly because we don't want this to run right away. We actually want to wrap and everything in a function, more or less.
Right.
And that it's funny because you're calling a function that wraps the function. If you look at the code, this function doesn't get called in the output because it knows you're just calling a function that you're passing a function to. But obviously, if you had another transformation in here, then we'd want to wrap this whole expression in a function. So that's what our JSX transform does. It creates real DOM nodes, and it makes every expression evaluation, like not an event handler, because that's a system called you kind of thing. It's different, but generally most expressions are just the big difference between React's transform and Solid's transform is that we wrap the expressions in functions and we create real DOM nodes instead of virtual DOM nodes.
Right.
So.
And I think one of the interesting things is that JSX doesn't seem like it's the only option for Solid, right? Like there's also the HTML template loop. Which is pretty cool.
Yeah, I can't optimize it as well because I can do some smart stuff looking at this. Like you see how I go, oh, this is why we use these function calls, because in theory, when it's just a function, you could just pass it straight through and it would work. Knockout had this problem too. I call it a problem because the language has to support this the way it works, so that you can pass functions, but it becomes ambiguous in terms of like when you call a function. And the second you go from double count to double count times 5, you need to add the brackets. And I hated that back and forth. So I tell people always to use the function. But when you're using something that can't analyze the holes, like the standard JSX transform, which also works for Solid, but kind of awkwardly, or HTML, you kind of have to wrap the function yourself. And actually, on that note, can I just pull up a quick code sandbox here to talk what I'm talking about? This is more on the extreme, and we should get back to the basics again, but I just wanted to emphasize, just for anyone who's like maybe has some questions or doubts on this whole concept, this is no compilation tag template literals. What I mean by that is like, see HTML tag, and then these are like, I've got some link components and suspense and routes. This is like concurrent rendering, transitions, solid app router, like the whole, React 18 future stuff, all done with tag template literals, no compiler. And like, see that dot there? That's the pending state. Well, this loads. See, this is a transition. It's like loading this on the background and then putting this into place. When you do the load, you get the more typical loading indicator suspense. Like this is lazy components. This is the whole like fully functional Solid without a compiler. This is you don't need a build step for this. And as I said, React can do this too. Like, this is nothing fancy, but when you compare it to things like, say, Svelte, this isn't, their approach doesn't really lend to this, because the reason this works so well with Solid is, as I mentioned, this HTML is getting compiled, but our approach is completely runtime. It's just doing the same exercise we did at the beginning, right? The biggest difference here is, see how I had to wrap this in a function myself, right? I had to go, function is routing expression or expression. Like, I needed to do this myself. Whereas in the JSX, you just be like, you just, the stuff inside the brackets, you just be able to write this in JSX. You just go, is routing. It's a small thing. It does trip people up. I think it makes the DX for this a lot worse. And with HTML, you have to do stuff like this. Like, when you want to make a child element, you have to, in our case, make it a function to make it dynamic, and then call HTML to then enter the new HTML scope. Like, this is not the nicest experience, in my opinion. But for some people, this is really cool, because, like, look, it's just the same pattern again. Like, here's the route provider. I'm just like this, the provider wrapping the app. And for components, you can just use // so you don't have to type it again. And you more or less have the full capability of the framework, minus a few performance optimizations and some nice DX things, without a compiler. So this is the biggest difference, as I said, because when people come, they're like, oh, Solid's a compiler like Svelte. That's how it's so small. That's how it's so performant. And it's like, not really. Yeah. Solid is actually mostly a runtime approach that is just really small and performant, because literally, like, at its core, it just takes a simple library and everything is built with it. Everything's reusing the same thing. When we go add a new feature, or like, the whole renderer is built using like Solid's primitives, essentially. Like, because I already showed you, like, these are just some create effect calls kind of, littered throughout the compiled code. Like, when people look at Solid's compiled code, they aren't like, oh, what is this other thing? It's not quite as transparent as HyperScript with JSX, where it's just like, all of these are just function calls. Essentially, there's like a little bit of direction in terms of, there's like some templates that get cloned, but generally speaking, it's only this that actually gets compiled, and it just gets compiled into the stuff we were writing at the beginning of our talk here. Like, you can see it right here. Double count. These are the same. And then this fragment is an array. And then we're cloning a template, and we're inserting, and then we're cloning another template, and then we're setting a click handler. This is a little fancy because it uses event delegation, but this click versus on click it's almost the same as what we were, like, our original code. We had on click instead of $$ click, but and instead of clone node, which just takes a template and clones it, we were calling document create element. But essentially, this is the same code we were writing, and that's a big thing here.
Oh yeah. Lazy DK is asking, is nested template and element prop needed because of the lazy loaded? Talking about the template.
Take template literals. No, it's any time. Well, actually, that's a good question, right? Because I was going to say, anytime you escape into $ land, like into JavaScript land, you need this again. There's a reasonable chance that, I'm trying to remember, because element wants a component. Yeah, this is what always kills me about this version, because you might be like, does this still work if it's not a function? And you know what? I think it does, because this one isn't dynamic, but like, if it's lazy loaded, does it work? This is why I don't prefer the DX of this, because you have to start being like, oh, how's the reactive system work? Does this work? Yeah, it's because the internals, the lazy handles it. So yeah, this was overkill. So we actually don't need the functions there. That's a good call. But it didn't hurt, but it also didn't do anything. And the real question is, can you do this? And I suspect we can't, but that maybe that's just on my parser, because there's no delimiter. Like, and it's not a string. So the only way to do rich values, like in this lit template approach, is through escaping into the JavaScript land. And if we escape into JavaScript land, to get back in, you have to use HTML. So we were able to get rid of the extra wrapper, because that wrapper is happening internally inside the lazy components, essentially. So the component stays the same, but its internal switch. But like for something like this, if we didn't have this wrapper, it would not work, essentially. Because like here, if you look, when I go to profile, actually, you know what? We do need the wrapper. It's not actually triggering the transitions. See, this is why. This is why I'm not a huge fan of. I probably figured this out before in the past, and I knew this, but there it is. See the transitions?
Yeah.
So this can be, you have to be a reactivity expert, I feel, to use this form. So my bragging rights on no compiler might not be like completely thing. Like, but for some people, and I've met them, they don't mind this. They understand the reactivity enough that they can just go and use this, and they're like, no build, and that's really important to them. I'm personally not, that's not my thing. I did build this originally kind of as a proof of concept and kind of enable these things. But like the thing is, when you use the compile JSX, it's easier to write, it's more performant, and it generates less code. It's basically better in every possible way. So, I mean, I know people are, I know there's reasons for the no build thing or whatever, but it's like, the performance loss here isn't bad. Like on a JS framework benchmark type thing, it's like 4% or something. Or 3%. It's not a big loss in performance. It still keeps, it's closer to solid than it is to, say, other frameworks. But it's just one of those things for me personally, because like I want to have if I know I could have smaller code, know I can have faster code, and know I can make it easier to write, that's what I want to do. I'm not going to be held up on like some idea of no build or whatever. Anyway,
right. Although to one of the commenters' points, quote, I think that template literals are a great way to show people that this is not a compiler-based approach like Svelte. So right to your point, what you were saying earlier, this really helped me understand, because originally I thought the same thing. I was like, oh, is some of the ways that it's so performant a compiler? And the answer is no. And that's really, really cool to see. So.
Yeah, and the thing is, I mean, this is the biggest challenge with this framework, is because the first thing people do is they see it and they go, "Oh, it's React," and then someone's like, "No, it's not React. It's blah blah blah," and then like, "Oh, it's Svelte." And the truth of the matter is, it's neither. I feel like we've carved out a unique space here. I think it's really surprising, because on one hand, the thinking is like, all JavaScript frameworks are kind of the same. And let's face it, they kind of are. But on the, and I kind of let it slide a lot when people are like, oh, Sol is just like a nice evolution over React, like a subtle, improvement on like stuff, because you don't need to use callback, or you don't need to put dependency arrays, on your stuff. It just, on your hooks or whatever. It's just, a nice subtle improvements. But I actually think that what we're seeing is like, this is a fundamental rewrite from the core. Right. Like this is actually very different than almost every other framework. Actually, I say almost, but I'm going to say every other framework, because it doesn't update with a component model. It like even the ones that use reactivity, like the closest framework to Solid is actually Vue, which surprises people a little bit, because our reactivity and Vue's reactivity are very similar. But at the time I started Solid, Vue didn't have the composition API. They weren't exposing that, and it always like bugged me a bit, because I'm like, I know it's in there. I know, like, don't be afraid, let it out, Mm-hmm. And they eventually did, but like essentially that's the core basis. The difference is in Vue, they take that reactivity to figure out how to update a VDOM. Essentially, this becomes, their templates or whatever, or virtual DOM, and they basically figure out how to optimally update that virtual DOM and then do the diffs. Where it's Solid, we just remove the virtual DOM. But it wasn't like a conscious, like I'm trying to remove the virtual DOM. It was more of like what I showed you today. It was like, we're writing vanilla JS, we're adding a little bit more functionality, we're adding a little bit more abstraction on top. And in the end, a little bit of abstraction suddenly gets us to a point where it looks and feels maybe like other frameworks, but it's just doing so much less.
Right. Well, and like you said, like, oh, it's a little bit nicer. It's a mild improvement. It's like, maybe, but to get that mild improvement requires a massive fundamental shift in how you perceive what you're working on, right? And that goes all the way down to the framework level. So this is really, really cool to see. So I know that we're coming up on an hour. I figure someone had mentioned the Solid has its own hackathon. Do you want to touch on that a little bit before we get going?
Yeah, definitely. This is something that I'm the most terrible at. I get really excited about the technology, and then I kind of get drained away. But Solid only hit 1.0. This summer. I've been working on this since 2016, doing little things, but the biggest gap we have right now is we don't have a big ecosystem. People are building libraries and working stuff every day. I see new stuff, new libraries coming in. I'm always like reposting them because they're just surprising how much stuff is coming in, from custom 3D renderers to people working on Meteor plugins or whatnot. But we wanted to kind of promote that kind of growth and give people opportunity to shine. And the way we figured out how to do that was this hackathon. It's a long running hackathon. It's a little bit different. Most of the time hackathons last like a week or a weekend, and you kind of put something together. We wanted the effort and the product of this stuff to actually potentially be lasting pieces in our ecosystem. So we went to a bunch of sponsors and we raised, $12,000 to kind of put together 3 categories for this. And the idea here is that, we don't want you to be stressed because we in a sense, the hackathon is asking for a bit more being such a long run, but we don't want anyone to be stressed for time. So we're like, if you have some time in the next 3 months to put something together, try out Solid, find maybe a hole or something you think is missing and build that, you have the potential to win thousands of dollars. That's essentially the thing, right? It's going to help our community. It's going to be good exposure for everyone and about the amazing things you can do. It maybe gives you a reason to try SolidJS for the first time, because maybe, at your work, you're probably not going to get a chance to do that for a little while because, there's, much more popular and known options out there. But this might be the little push you need to give things a try. And
that's awesome.
That's the whole idea here. I think it's really awesome to see people kind of participating already and sharing their stuff and, getting on social, tweeting it and whatnot. And we'll do everything possible to kind of promote that as well, so people can check out your library. Because in the end, this is actually based on a voting system, which, might seem a popularity contest, but Solid isn't very popular itself. So, I mean, I'm less worried about that, although it's something we keep an eye on. But generally, the idea here is like, just kind of come in unbiased, give it a shot, see if you like it, and build something cool. Yeah,
that's awesome. This has been so cool. Thank you so much. This is like sincerely, I knew that this talk was going to this interaction was going to be really, really cool. It was so much cooler than I thought it was going to be. And I'm blown away and impressed. So count me in for the hackathon. I will absolutely be participating. I don't know what I'll build yet, but that's part of the fun, isn't it? So, and then on that regard, y'all, that's going to be it for today. We do live streams every once in a while, so we're trying to do bi-weekly. So join us the week after next, where we are joined. I want to say next week is it James? I want to say James from Tina CMS. Anyways, I'll make sure the socials are updated, and that if you set the notifications enabled for the stream, that you'll be sure to catch it. At any rate, Ryan, thank you so much for joining us. It has been a pleasure.
Yeah, that was a lot of fun. Thank you so much.
Yeah.